Hello guys. So computers, as we all know, are good at doing many things quickly. Actually, very many things and very quickly. For example, let's create a simple function that does something. In our case, it will just sleep for 1 second. And we can run this function many times. N times. We do it like this. We create a loop. And call the function repeatedly. Now let's run this. So do many things, let's say 10 times. Now, if we run this program and we time it, it should take around 10 seconds. But what about we want to do this something 1,000,000 times? We don't want to wait for 1,000,000 seconds, which is almost a dozen of days. The way we structured this program is called sequential programming, meaning we do this something one after another. So we do something, wait for it to return, to finish, then we do something again, we wait for it to finish, and so on and so forth. But there is another way how to structure a program, and it's called concurrent programming, which doesn't wait for a function to return, but continues the execution. And we do it simply by using the Go keyword. But we also need to do some counting of started and finished functions. And for this we use a construct called sync wait group. Wait group, which is a concurrency safe counter, nothing more. And each time we launch a function on a new Go routine, we increment this counter by 1. But then we also need to decrement it when the function is finished. So we do it like this. Differ vg done. So differ means that this statement will be executed after this function is done, and we do our something. Now we also have to wait for this counter to become 0, meaning all functions are done. Okay. And now let's say we can do 1,000,000 things, and let's time it. Around 3 seconds instead of 12 days. Not bad, right? Okay, that's nice. But as we can see here, our function do something doesn't produce any output. What about a function that produces some output, like an error message? So let's simulate an error, like every 1% of the runs of this function will return an error. We got a problem. This is the error message. And 99% of the runs will be fine. No error. Now we need to change this do many things function to handle the output. For this, there is a construct in Go called channels. We create a channel like this. We give it a type, and we can buffer it so it can hold n items. We do the loop, and we launch the function on the Go routine as before, but we capture or we send its output on a channel like this. So output of do something goes to the channel. Okay, fine. But now we need to read from the channel. So we create a range loop again. We read the errors from the channel like this. And if it's not nil, we store it to errors variable. We need to declare our errors variable here. Errors is slice of errors. And we return the errors. Slice of error. Okay. So we see we don't need to use the wait group anymore because channels are used both for communication, like sending on a channel and receiving from a channel, and also for synchronization. Because here in the second loop, we loop n times and we know there were n sends on the channel. So if we receive n times from the channel, we are sure that all Go routines are done. Okay, now let's run it, and we can do some printing of output, doing these many things. There were this number of errors. Okay, let's put this in a variable so we can reuse it. 1,000,000 times we set, and let's run it. And define the errors. Okay, doing million things, there were around 10,000 errors, which is 1%.